Hello, ladies and gentlemen. Welcome to another lesson, Pre-Calculus for Business with Professor Checo. Today's lesson, 7.4, Permutations and Combinations. So let's go ahead and take a look at this chapter. We have 26 questions, all right, and textbook. All right, so permutations and combinations. So in this chapter, we're going to deal with factorial. So first, what's the definition of factorial? Factorial is when you have a number and you multiply it all the way down to 1. So 4 factorial is 4 times 3 times 2 times 1. Just computing factorials, no problem. All right, so permutation of set of objects. So the way that I remember this, you have a permutation versus a combination. A combination lock that you would have on a school locker, like a traditional one that you were used to, the master lock, that is actually a permutation lock because it is an arrangement of objects in a specific order. So we should be calling them permutation locks, not combination locks, because combinations is when order does not matter. So once you have any combination of 3 things, it doesn't matter which order they are, you have that 3 combination. A permutation, it does matter. So permutations would be factorial, you just multiply it. Given a certain number, if you're permutating that number, it's just the factorial. So for example, how many ways can 7 objects be arranged in order? There's 7 factorial. Taking R at a time, so that would be if I have 4 objects, but I'm only picking 2. So that would be 4 permutation 2, which is just going to be 4 times 3, because the 2 and the 1 would cancel out with the 2 and the 1. That's just, how we use it. And then using a diagram, this would be it. So permutation, how many orders, 1 out of whatever. It's just different ways to think about it. But that's pretty much what a permutation is, and the calculator can do all that. A combination is when the order does not matter. And that would just be, we use our combination factor. 3C2 is when you have 3 objects and I'm picking any 2 of them. So here, 3 objects. 1, 2, I'm sorry, these are 2 objects. Whatever. Terrible example. Taking R at a time, yeah, NCR. That's just permutation. Got it. So here, like, if I have 8 objects and I'm picking 3 of them, so I have 3 slots. So it's 876 divided by the 321, and yeah, certain things cancel out. Cool. It's all going to cancel out. If a permutation, order is vital, and a combination, order is irrelevant. Yep, exactly. That's really the main thing. Deck of cards. If these are deck of cards, then you really have to think about how you're going to break the deck into its spaces. So like how many 5 card hands have 3 aces and 2 kings. So you really got to figure out how to pick that. So out of the 4 possible aces, I want 3 of them. Out of the 4 possible kings, I want 2 of them. So it's 24 possibilities out of however many possible outcomes hands there are, which would be whatever, and so forth. So I'm going to get into that when we get into actual problems and counting officers. Yeah, matched. And all right, let's done. This is just math. Multiply, done. Multiply, done. 5 factorial, it's an integer value. 5 times 4 is 20, times 3 is 60, times 2 is 120. All right, I'm not multiplying. 7 factorial, yeah, 7 times 6 times 5 times 4 times 3 times 2 times 1. 26 minus 20 is just 6 factorial. What was 5 factorial? Whatever, multiply. 18 divided by 15 is going to be some number where this is just 18 times 17 times 16 because 15 and all will cancel out. So I don't know what 18, 17, and 16 is. I need a calculator. What's 18 times 17 times 16? 4896. So that answer is 4896. 4896. 6. 4896. 18, 17, 16. 18, 17, 16. 4896, 4896. Round to 4 decimal places as needed. It is an integer. 18, 17, 16. 18, 17, 16. 4896. Oh my god, why did I write stupid 4896? That was dumb, isn't? Whatever. All right. So as you guys see, same exact thing. Just plug it in. You'll figure it out. You multiply. All right. So 11C2. So which is the definition? I think it is. This is not right. I think it's this one. It's a combination. Would be n 2 11. Oh, that's 11 minus 2. I think that's what it is. Yep. And that's just the definition of combination. What would that value be? 110. 11C2, 11 times 10. 11C2 is 110, isn't it? Can I do combination? 11C2. No. Let me go back to Desmos. Is there a permutation and combination calculator? What was that? 11. Oh, I'm so dumb. I did it in a permutation. They were looking for a combination, weren't they? Oh, it's 55. You divide it by 2. 55. Got it. Cool. All right, 7p2. I believe that one is just this, right? Where this is 7, this is 2. No. This one, 7, 7, 2. That's it for permutation. Now this one's going to be 7 times 6, which is just 42. Got it. All right, so now evaluate this expression. So 25C2. So we could just do 25C2, calculate, that's 300, and 345C2. So that's going to be boom, 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 boom. That's going to be 300 divided by 45C2. 45C2 is 990. And that gives us 990, 30 over 99. I think that's 10 over, no, 3 over 30 over 99. I think that's going to be it, right? Oh, they just want what it's equal to. This one is B. So this is n factorial, which is going to be 25, and then 225 minus 2. And C of 45 is 45 to 45 minus 2. Was that it? Yeah. And then that answer is not an integer. It is, what do we get? 30 over 99. 30 over 4 decimal places. 0.3030. There we go. Hopefully that made sense. All right, simplify in factored form. I don't know what they're looking for. What are you looking for? Just that? What are they looking for? N times n minus 1, n minus 2, n minus 3, n minus 4, n minus 5. assume n is greater than 6. So then I would just do all the way up to whatever the number is. So for example, I don't want to do 7. 7's too big. 9 is big. 11. 4. So let's do 4. So that should be n minus 1, n minus 2, n minus 3, like that. Okay, so if it was a higher number, we just have to go up to a higher number. All right. Is the selection permutation, combination, or neither? The prom king and queen are chosen from the senior class. Obviously, the prom king is male, the prom queen is female. The order of selection process is irrelevant. The prom king cannot be the prom queen, thus there is no repetitions in the selection process. Therefore, the selection is a combination. Yeah, I'm going to say combination because if I pick a male first, female second, as the prom king is male and female, the order of the selection process is vital. Also, the prom king cannot also be the prom queen, thus there are no repetitions in the selection process. Therefore, the selection is a permutation. I don't think it's a permutation. I still think it's a combination because the order does not matter. Permutation, as the prom king is male and prom queen, the order of the selection process is irrelevant. Also, the prom king cannot also be the prom queen, and thus there are repetitions in the selection process. I'm still thinking it's a combination. I'm wrong. Is it the other combination? It was a permutation. Also, the orders. That's why the prom. But they didn't say that. They just said they wanted a prom king and queen. All right, let's try it again. A coach chooses a quarterback and a kicker, so it's a permutation because order matters. So it's either A or D. The order also a player. So as the positions on the team are specific positions, the order in the selection process is vital. A group of 3 senators is chosen to be part of a special committee. This is going to be a combination because it doesn't matter who I pick first, it's still the 3 senators. So this is a combination. It's either, it's A. Um, 10 jockeys choose red, green, or purple shirt before a horse race. I think it does matter because you have 10 jockeys. So as a red shirt is not the same as a purple shirt, the order in the selection process is vital. It's a combination. What is it? No, it's neither a combination nor a permutation. As the red shirt is not the same as the purple shirt, the order in the selection process is irrelevant. I understand that, which would make it a combination. Also, there are only 3 different shirt colors and 10 jockeys need to pick a shirt. So there will be repetition in the selection process. Therefore, the selection is neither a combination nor a permutation. That makes sense. So let's go similar question. Let's say it's neither a combination nor a permutation. So a father orders ice cream, 3 selections for his 5 children. So there will be repetition in the selection process. That makes sense. In a horse race, how many different finishes among the first 3 places are possible if 11 horses are running? So I have 11 horses. I'm picking 3 of them in a permutation. So I have 11 horses, and I am picking 3 of them to finish. Calculate. There are 990 different ways. How many ways can a 3-person subcommittee be committed for a committee of 9 people? That's a combination. And president, vice president would be a permutation. So this is 9 sub 3. So let's go 9 and 3. Calculate. So I can make 84 different committees. And I can have 504 different ways to make that committee. A standard deck of 52 cards has four 13 card suits. Yep, the diamonds in the heart are red, the clubs in black. Each 13 card suits with numbers from 2 to 10, a jack, a queen, a king, and an ace. The number on the blah blah blah. So there are 13 ranks of and 4 cards. Okay, so from a standard 52 deck, how many 2 card hands consist entirely of black cards? So I have 52 cards. I'm sorry. There are 26 cards that are black, right? Because the clubs and spades are black. So I have 26. I'm picking 2. So that would be 26, pick 2. Calculate. Now this is a combination because once you have a hand, it doesn't matter if it's first, second, or third. So this would be 325. There are 325 different hands possible. Okay, from a standard deck, how many 4-card hands contain all hearts? Well, how many 4 hand cards? Well, how many hearts are there? 13. So I have 13 cards to pick from, and I need 4 of them. Now it doesn't matter. There's 715. 715 different ways that I can get all hearts. A catering service offers 6 appetizers, 11 main courses, 7 desserts. A banquet committee is selected 3 appetizers, 6 main courses, and 5 desserts. How many ways can this done? So I need to figure out 6 appetizers would be 6 choose 3. So let's do that. 6 choose 3. So we have 6 options. I'm picking 3 of them, and it doesn't matter. So there's 20. So I'm gonna go to Desmos. I'm gonna clear that, clear this, and let's just write that there are 20 ways here. Let me zoom in just a little bit. Whatever, doesn't matter. Back to this problem. So I have 11 courses. I get to pick 6. So that would be 11 pick 6 would be 462. And then 7 desserts, I can pick 5. So if I have 7 desserts, I can pick 5. That would be 21. And I think there's 194,040. 194,040 different possible ways because you multiply. There you go. Discuss the validity of each statement. In this statement is true, explain why. So if n and r are positive integers and r is less and 1 is less than r less than 10, then that CR is equal to n. Alright, so what this means is if I have 7 choose 5, that's 21. That should be the same thing as 7C2. And it is 21. So it is true. The number of ways 4 people can sit in a row of 8 chairs. 4 ways 4 people sit in a row of 8 chairs. So I have 4. I'm going to pick 8. Yeah. Or is that 8 pick 4? 1680. 1680. Because basically I'm assigning 8 chairs to the 4 people. A sports team has 5 distinct positions. Out of 8 players, how many of them can... Alright, so a sports team has 5 distinct positions. Out of 8 players, how many starting teams are possible if the distinct positions are taken into consideration? So 8 choose 5. 6720. If each position is taken into consideration. If they're not, then it's 56. There are blank teams if distinct positions are not taken into consideration, but either Mike or Ken, but not both, must start. So then I think that's 7 choose 4 because the first one, I think it's 7 choose, I missed the 7 up here, 7 choose 4, which would give me 35 times 2 should be 70 because the first two people, so there should be 70 total ways. No. Is it 35? No. Mike or Ken? But 2 choose 1 is 2. Yeah, so that's 2. And then it's 7 choose because one person is playing it. And then there's 4 more spots available. Right? Choose 4, calculate, and it does not matter, so it should be 35 times 2, which is 70. I don't know why it's not 70. Correct answer is 30. Why is it 30? I know why. Because not both. So if you think about this, it's like I have 2 people to pick from in the first one. Then I have 6 people to pick in the second one. Because I can't use Mike 6 times 5 times 4. What is, hold on. What's 6 choose 3? Is 20. Interesting. What did they say? How did they explain this? There's A, there's C. So here's C. So as distinct position to consideration, there are the first 2 positions in the starting that need to be filled. There are 4 players. Now continue this section. Therefore, 1 player, 2 ways. Yeah. Now you have 4 players, either because Mike are placed in the previous step, or Mike and Ken cannot be considered in the remaining steps. I gotcha. There are 2 positions in the starting team that need to be filled. There are 4 players and 2 positions. Yep. So the last 2 needs to be 4 choose 2, which gives us that. And multiply 2 times that. Therefore, this. So you're telling me that if I would have done on this question, if I would have done 6 choose 4, 6 choose 4, calculate, that's 15. 15 times 2 gives me 30. Got it. An election store receives a shipment of 30 graphing calculators, 2 that are defective. 4 of the calculators are selected to be sent to the local high school. How many selections can be made? Is it 30 combination 4? 30 combination 4 would be 27,004, 27405, 27, 27, 27405. with no defective. Selections will contain no defective, so that should be 27. 17550. 17550. That's it. A jewelry store chain with 5 stores in state A, 10 stores in state B, and 12 states are planning to close 12 of those stores. Complete. How many ways can this be done? So there are 5, 15, 27. So I have 27. I'm picking any 12 of those. 27C12. 1738. Oh my goodness. A lot of stores, a lot of possibilities. The company decides to close 2 stores in state A, 5 in state B, and 5 in state C. And how many ways can this be done? So I gotta just multiply. So 5 choose 2, right? 5C2. 5C2 is 10. 10C5 is going to be 252, Desmos times 252, and then 5 and 12C5, 792 times 792 would give me that number. I didn't grab all of it. Copy, paste that in there. There you go. That's how many ways you can close it. There are 8 standard classifications of blood type. As an example, determine for how many different examinations can be given if no 2 of the samples provided from the candidate have the same type. How many different examinations can be given if no 2 of the samples have the same? So that's a permutation. So that would be 4C2. Is it 4? An examination 8C2. C2. How many different examinations can be given if no 2 of the samples provided for the candidate have the same type? And the type for 4. Permutation. Oh. Whoa. 8. So then this one would be 8P8. What? Correct answer 8P4. And what is it? 8 to the 4th? 4096. I doubt it. What's 8 to the 8? Let's try that number. What is this question asking? 1680. Huh? I really have no idea what this question is asking me. Was this 8C4? 8P4? 4 to the 8 maybe? let's do. Oh, I took the wrong one. Oops. I didn't want Desmos here. Let's put that back. Let's go here. What is 8 pick 2? Calculate 28. No. 8 pick 4. 1680, 1680. There we go. Numbers in the beginning of 2 and the same type is 56. I don't know. 1680. 2 4. That times 2, right? It was that answer times 2. Oh, whatever. Yeah, you got it. All right. Put that back. Question. Here we go. In how many ways can 5 candidates for an elective office be in a ballot? Oh, be listed? Yeah, 5. 5 factorial. Number of ways: 5 times 4 times 3. 5 times 4, 20. 80. Wait, 5 times 4 is 20. Times 3 is 60. 120. Cool. And that was the last question. Awesome. So pretty straightforward, not too bad. Permutations and combinations, a lot of calculator. I used this website, calculator.net, and went to the permutation and combination calculator. It's more of the understanding when it's factorial, when it's going to be divided by, and so forth. All right. Best of luck.